So yesterday we noted that we take these trig ratios relative to a particular angle in a right triangle. That is to say, we take the sine of an angle. We take the cosine of an angle. They are functions. You have to give these ratios, sines, cosines, tangents, an angle, and it'll spit out a number for you. Now, on a modern scientific calculator, you do have buttons to calculate trig ratios. I mean, if you check your scientific calculator, there's a sine button, there's a cosine button, there's a tangent button. But you know what? There are times when we don't want the decimal approximation, or there are times where you don't have a calculator handy, or there are times where you just need to know how to do it by hand. So how do we evaluate these trig ratios? How do I figure out what sine of 30 degrees is or what cosine of pi fourths is really fast and easy without a calculator? Well, there's basically two methods, right? Oh, crud, I forgot my lesson objectives. Let me go ahead and write down my lesson goals. We only have one lesson goal here, so it's sort of an interesting paradox. We only have one goal, but there's a lot of buildup, and that is to find the trig ratio for certain angles without a calculator. Right? And like I said, there's basically two particular methods. One method I like, one method I don't particularly like. Method number one. Straight memorizing. It's not glamorous. Memorization. There is some good mathematical foundations to this, though. So let's talk about the theory and logic behind it before I just say, okay, good, now go off on your own and memorize. This idea sort of blends algebra and geometry into a wonderful, wonderful concept. So suppose we had a circle, right? And you decided to put this circle on a coordinate system. And just to make life easy in ourselves, let's make the radius 1. Because 1 always makes math easy. The word 1, or rather, when anything is 1, 1 over 5, a radius of 1, you have a length of 1, we call that a unit. And since this shape is a circle, we call this a unit circle. So I hope we agree that every single point, if this is a coordinate system, every single point on this particular circle has a location, x, y. Well, what does that x and y stand for? Well, the reason why we denote this point has a location of x means if we go horizontally, that has x units length, and if we go vertically, that has y units in length. Now, because I denoted the radius as having 1, what we've created is a triangle, specifically a right triangle. Now, if I focus on the angle from standard position, notice we can find or create some trig ratios with this, right? From this picture, we can see that the sine of that angle, opposite for hypotenuse, is y. I didn't decide to put over the 1 because anything divided by 1 is itself anyway. And then the cosine of that angle is x. And the tangent of that angle, even more important, opposite over adjacent, is y over x. These guys here are fundamental, critical in being able to use a unit circle. Well, what is a unit circle? A unit circle is sort of like a mathematical cheat sheet of some trig ratios of special angles. Now, you can do this on your own time. Open a web browser, go to Google, and type in unit circle, and you'll see some image that looks like this, right? So that is one particular way you can do trig, is just to memorize this. Now, how in the world are we supposed to utilize this? Well, let me see if I can copy and paste this, if I remember how to do this. There we go. Oh, no, I don't want that. Where's it double? There we go. Nope. Come on. Sorry for the technical difficulties. What you can do if you memorize this, which again I highly don't advise, but you could. Paste. There we go. Is we're going to use the fact that the x-coordinate is cosine and the y-coordinate is sine. Right. We're going to utilize these facts here to be able to evaluate certain trig ratios. So from this chart here, answering questions should be easy. What is sine of 300, right? I'm asking for sine. According to this logic, sines are the y values. So I look at the angle 300. Oh, here's 300. What is the y value? Oh, the y value is negative 3 over 2. Therefore, that's the answer. Sine of 300 is negative radical 3 over 2. What's cosine of pi? Well, I know that the cosine are the x values, right? So, okay, I look at the pi radians. Here's pi. So here's his coordinates. What is the x value? Oh, the x value is negative 1. So I know that cosine of pi is negative 1. So you can see how if you have this chart memorized, answering or finding trig values is just a matter of looking. It does have its flaws. Well, it doesn't have its flaws. You do have to do a tiny bit of thinking, especially when it comes to tangents and cotangents. For example, if I asked you to do tangent of, 3 pi halves, you just have to remember that tangent is the ratio of y over x. So I look at 3 pi halves. Here we go, 3 pi halves. So I do the y value, negative 1, over the x value of 0. Don't just leave it like that. You actually have to do some thinking. You should know that, oh no, we can't divide by 0. So this is actually undefined. So just do a little bit of thinking, guys. Don't just run on autopilot. But this is a valid method. Just memorize this picture and go with it. Let's do a reciprocal function. Let's say I ask you to do cotangent of 5 pi over 6. We just have to remember that cotangent is the reciprocal of tangent. So the way I like to do this is I do the regular tangent, y over x, and then just flip my answer. So cotangent of 5 pi 6, where's 5 pi 6 on this chart? Here we go. I know that tangent is y over the x, so I'm going to do the exact opposite. This is going to be x, negative radical 3 over 2, over the y. And of course, you got to simplify this compound fraction. Dividing by a fraction is the same thing as multiplying by the reciprocal. And of course, that gives us negative radical 3. So this is not my preferred method, but I have had some kids in the past that are absolutely stubborn. No, Mr. Vo, I just want to memorize a circle. You're more than welcome to do that. I think that's wasted brain space personally, but that's just me. The method I much prefer is to utilize everything we've learned. Right? We've learned about coterminal angles. We've learned about reference angles. We've learned about quadrants. Now all you have to do is squeeze in special triangles. There are 2 special triangles that you should have learned in geometry. I'm going to write them down now. If you don't remember where these triangles came from, or you've never heard of these triangles before, please let me know and I'll gladly show you where they come from. But the 2 special triangles we should have learned in geometry is the 30, 60, 90 triangle and the 45, 45, 90 triangle. So unfortunately, there is some stuff that you need to memorize, but I think it's less memorization than the whole unit circle. Okay. These special triangles are named thusly for their angles. So it doesn't really matter where I'm labeling because it's just not drawn to scale. But let's just say that this is the 30 degrees and this is the 60 degrees. And let's say that this is 45 degrees, 45 degrees. The reason why we call these special triangles is because their side lengths are relatively simple. In a 30, 60, 90 triangle, you need to know that the side lengths are 1, which is opposite to the 30, radical 3, which is opposite to the 60, and 2 for the hypotenuse. I like to think of it as 1, 2, square roots of 3. And for the 45, 45, 90 triangle, the side lengths are 1, 1, and the hypotenuse is 2. Although I call these the 30, 60, 90 and the 45, 45, 90, we do also have to be cognizant of their radian measurement. So we do have to remember that 30 degrees is pi 6, and 6 degrees is pi thirds, and 45 degrees is pi fourths. And of course, it's going to be the same on either corner. Well, how does this sort of like help me? How am I supposed to use this, right? Because it looks like, okay, I have the triangle now. I can read sine and cosine. Duh, right? What is sine of 45 degrees? I can just read, oh, here's sine. Use SOHCAHTOA. Here's 45 degrees. Use SOHCAHTOA. Opposite over the hypotenuse. It's just 1 over radical 2. What's cosine of 60 degrees? Oh, here's 60 degrees. Cosine is adjacent over the hypotenuse. Oh, so that's just 1/2. What is tangent of pi fourths? Oh, tangent is opposite over adjacent. So here's pi fourths. Opposite over adjacent. Oh, that's just 1 over 1, which is 1, right? But of course, the question is, what about obtuse angles? What if I don't have an angle that's 45 or 30 or 60? What about obtuse angles? We need to recall from earlier that the x-coordinate relates to cosine, and that the y-coordinate relates to sine. That is a very intimate relationship. The second thing you need to recall is how a coordinate system works. In a regular coordinate system, you have x positive going to the right, x negative going to the left, y positive going up, y negative going down. Which means if x relates to cosine and y relates to sine, that in the top right quadrant, in quadrant 1, cosine of any value in the first quadrant should be positive, because in the first quadrant, x, ooh, that was bad, x is positive. Sine is also positive, because again, in the first quadrant, sine is positive. And knowing that tangent is the ratio of them two. If I divide positive with positive, I know that tangent is also positive as well. Well, but we can finish this chart in the other quadrants, right? So in the top left corner, in the second quadrant, notice how x is negative and y is positive. Well, if x is cosine and y is sine, that means cosine is negative, sine is positive. And if tangent is those two guys divided, positive divided by negative, I know that tangent is negative. Let's see if you can't finish the chart before I do. In the third quadrant, x and y are negative, so both cosine is negative and sine is negative. And since tangent is them divided by each other, negative divided by negative is a positive. In the right quadrant, in the bottom right quadrant, quadrant 4, x is positive, y is negative. So I know that cosine is positive, sine is negative. And of course, if I divide them to get tangent, I get a negative. It seems like it's a lot of memorization. Let me see if I can't move this. It's way a bit too close. It seems it's a lot of memorization, but it really isn't, because it's just basic understanding of the coordinate system, which is what I think you guys should know by now. And the second thing that you need to know, reference angles. Reference angles are the positive acute angles, terminal sides make with the x-axis. So put it all together, to find trig values of, quote, special angles, you, step 1, find the reference angle. Step 2, figure out positive or negative based on your quadrants. And step 3, find the actual trig value using special triangles. So I like this method better because this is the only thing that you really need to memorize. Step 1, you should be experts at. That's what we practiced yesterday. And then 2 days ago. And then step 2 is you already know the quadrant system to begin with. I think this will make a lot more sense with a handful of examples. So for example, suppose I ask you to find cosine of 150 degrees. So, okay, let's do this. The first thing I do is I notice, oh man, 150 degrees, that's obtuse, that's bigger than 90. So I'm going to work with this reference angle. So if theta equals 150 degrees, hopefully everyone understands that its reference angle is 30 degrees. If that is troubling to you, practice finding reference angles. I'm not going to go through that spiel. What does all of this logic means? This means the cosine of 150 is equal to space cosine of 30 degrees. Anytime you do a reference angle, you always have to put a space because in here will either be a positive or a negative. Well, how do I know if it's positive or negative? I need to know what quadrant I'm in. I should know that 150 degrees is in quadrant number 2. Right there. Now, what trig function am I working with? I'm working with cosine. I should know that cosine relates to an x value. So here's my question. Are x's positive or negative in the second quadrant? I hope it doesn't take a long time to think about to know that x's are negative in the second quadrant. So I have to put a negative here. Right? So then let me just go ahead and mark down what everything means. So this negative here, since 150 degrees is in quad 2 and cosine relates to x's are negative in quad 2. And of course the 30 degrees is the reference angle. Now, since 30 degrees is part of the 30, 60, 90 special triangle, I just have to memorize the picture. What does the 30, 60, 90 triangle look like? I'm feeling too lazy. I don't want to scroll up. I should know that the 30, 60, 90 triangle looks like 1, 2 squared to 3. And then from this picture, I should just be able to read, what is cosine of 30 degrees? What is adjacent over hypotenuse? Oh, that is radical 3 over 2. So that's my preferred method. This right here, the unit circle, way too much to memorize. I mean, you're more than welcome to memorize it. Kudos to you. You have the brain power. But I find using special triangles, I find it easier to memorize these two triangles than it is to memorize this whole circle. And to prove my point, I'm just going to do a handful more examples, and you'll see how fast and quick this can be. So for example, sine of 210 equals, well, 210 is a big angle, so I'm going to use his reference angle. I know that the reference angle of 210 is 30 degrees. I know 210 is in the third quadrant. Sine, meaning the y values, are negative in the third quadrant. Knowing my 30, 60, 90 triangle, I know that sine of 30 degrees is 1/2, so it needs to be 1/2, or negative 1/2. Imagine how fast you can do this if you didn't have to explain every single step. Right? Honestly, these should be like 10-second problems, 10 seconds worth of thinking. Of course, we have to be proficient with radians as well. So 5 pi thirds is an obtuse angle, so I'm going to use a reference angles. So space, cosine of his reference. I know, because I've practiced radians and reference angles, that the reference angle of 5 pi thirds is pi thirds. I know that 5 pi thirds is in the fourth quadrant. Cosine is positive in the fourth quadrant. So then all I have to do is figure out cosine of pi thirds. Me, being good at radians, knows that pi thirds is 60 degrees, and cosine of 60 degrees is 1/2. Don't get turned off or scared if I give you a reciprocal function, cotangent of 11 pi 6. You go through the same motion. Okay, 11 pi 6 is obtuse, so I'm going to use a reference angle, so I need a gap here. I know that the reference angle 11 pi 6 is simply a pi 6. So what I'm going to think, tangent of pi 6. And then whatever answer I get, I'm going to reciprocate. Well, I know that tangent of pi 6 is 30 degrees. I know that tangent is 1 over radical 3. Therefore, cotangent of pi 6 has to be the reciprocal. If you flip this guy, it's simply radical 3. Oh, I forgot the space. I forgot the plus or minus. Well, 11 pi 6 is in the fourth quadrant, and knowing that tangent or cotangent is x and y divided, in the fourth quadrant, one is positive, one is negative, so when you divide them, you get negative. So cotangent of 11 pi 6 is negative radical 3. It just takes practice, guys. Honestly, it's no big secret. It's not anything nefarious. You just have to be good at it, and that is the expectation. This may be a simple section in concept, but it is such an important idea. We have to be fast at finding these trig ratios by hand without a calculator. And basically, on the quiz on Friday, it's just going to be a fast drill. Here's 20, 30 questions. You got 5 minutes, figure them out, that sort of stuff. So you will not be able to rely on your notes. There is one drawback, though, and that's finding trig ratios of quadrantal angles, angles that are on the axes. So for quadrantal angles, you're really forced to use the unit circle, right? But you don't have to remember the whole unit circle. You just have to remember, again, the quadrantal angles. Knowing that the radius is 1, it's pretty easy to figure out because it's just like regular coordinate systems, right? And you just have to remember, x is sine, or x is cosine, y is sine, and tangent is y over x. So with this, I can easily see that cosine of 3 pi thirds, well, cosine is 3 pi halves, excuse me. It's very late. I'm tired. Cosine of 3 pi halves, I know 3 pi halves is down here. Cosine is x's, so that's going to be 0. I know that, sine of pi, I know pi is right here, and sine of the y values, that's going to be 0. I know that, cotangent of pi halves, well, I know pi halves is right here. If tangent is y over x, cotangent is x over y. And, well, what a coincidence. I really suck at coming up with examples. That's also going to be 0. Just my luck. It's not always going to be 0, but that's just what happens here. So more of the story, if you have quadrantal angles, you can't use the special triangles. You have to use the unit circle. So simple concept, only one lesson goal, figuring out these trig values by hand without a calculator. But it's such an important idea. You need practice. Practice, practice, practice. Good luck.